All right, day 2 of distributing heat. We're on page 206. Convection in nature. Convection and convection currents play important roles in distributing heat around Earth. Distribute heat. Just like in the aquarium example, convection currents form in the Earth's atmosphere and oceans because of uneven heating. Atmosphere and oceans equal uneven heating. In Earth's oceans, water near the equator receives the most direct rays from the sun and is therefore quite warm. Okay, so in this picture you can see right here at the equator in the middle of the Earth, things are pretty warm. Near the poles, however, sunlight strikes at an angle, so ocean water is very cold. At the North Pole and the South Pole, things get colder. Okay, equator, warm, poles, cold. The temperature differences result in convection currents that form huge loops in Earth's oceans. These convection currents distribute heat throughout the oceans. Okay, so it goes from the equator to the poles and then eventually cycles back again. Different materials on Earth's surface absorb incoming solar radiation differently. Dark surfaces absorb a greater fraction of the incoming sunlight than do light surfaces and become warmer. Materials may also heat up at different rates. For example, water needs to absorb about 4 times as much energy as land to increase its temperature by the same amount. Okay, think about that for a second. 4 times as much energy has to be absorbed by water for it to heat up, the same amount as the land. So, ocean warms slower than land. Because land and ocean are heated unevenly, the air above them is heated unevenly too. Air above, heated unevenly. Cooler air that comes in contact with a warm surface will warm up because thermal energy is conducted from the surface to the air. Like the warm water in the aquarium, warm air expands, becomes less dense, and rises. As the air rises, it cools, becomes denser, and sinks back down toward Earth's surface. A convection current has formed. Okay, so warm air rises, eventually cools and becomes denser, sinks back down again. As the warm land warms up the air above it, it becomes less dense and it rises, keeps going in that convection current. Okay, now local winds. Local winds. Sea breeze. Over land during the day, warm air rises. Cooler air from the ocean moves in to replace it, forming a sea breeze. So a breeze coming in from the sea, a sea breeze. Again, both the land and the water are receiving the same amount of energy from the sun, but remember they said that water takes a lot more energy to warm up and get to the same temperature as the land? So even though the same amount of energy is hitting these two surfaces, the land is getting warmer than the water. Because the land's getting warmer, it's heating up the air above it faster, and so that hot air is going to rise, cool, fall, be swept in back to the land, rise, heat up, and you get that convection current during the day. So day, sea breeze. Land breeze. Over the ocean at night, warm air rises, cooler air from the land replaces it, forming a land breeze. Okay, so at night, remember how it takes 4 times as much energy to heat up the water? That means it also takes 4 times as long for it to cool down compared to air. So all that heat that the ocean got during the day, it kind of like holds onto it at night, and it releases it very slowly. So it's warmer out over the ocean than it is over the land. So that warm ocean warms up the air becomes less dense and rises, When it gets up closer to outer space, it cools down and lets off some of that heat, falls back toward the land. That cool air over the land gets sucked over here where the warm air was disappearing, and you get a convection current and a land breeze, which is blowing out from the land. So at night, you get a land breeze. See vocabulary. In other words, come over here to the land breeze and the sea breeze to see the little drawings that we did. And page 207 to see the pictures. So a sea breeze is air blowing in from the sea, and a land breeze is air blowing out from the land. Okay, let's go ahead and read here. Have you ever spent a long day at an ocean beach? If so, you may have noticed that the local winds blow in different directions during daytime and nighttime. The same type of event happens near a large lake. What causes these changes in wind direction? So if you ever go to the beach, something weird you'll notice is in the morning, and as it starts to warm up, you'll get this sea breeze during the day where it's blowing inland. And then if you go to the beach late at night when things start to cool down, the wind shifts directions and starts blowing out. During the day, the land absorbs more of the incoming solar energy than the water does. Remember, the land heats up faster? The water takes 4 times as much energy to finally get warm. It also heats up at a higher rate. As a result, land temperatures are higher than water temperatures. The air above land becomes warmer and less dense than the air above the water. This warm air rises, and the cooler, denser air above the water moves in to replace it. So that warm air rises, and this cool air moves in to replace it. The cool air that blows along the surface from the water towards land is called a sea breeze. Remember, we have that in our vocabulary. A sea breeze is really the lower half of a convection current. So this down here is the sea breeze, the lower half of the entire convection current. It forms in the atmosphere over the sea and land. At night, a convection current flows in the opposite direction. The land cools down more quickly than the water does, so the air above the water is warmer than the air above the land. Air above the water is warmer than the air above the land. Warm, less dense air rises above the water, while cool, dense air above land moves in to replace it. The result is a cool wind blowing near the surface from land toward sea, called a land breeze. Sea breezes and land breezes help explain why the air is often cooler at beaches than at places farther inland. So you're always getting that blowing cool air, whether it's coming inland or outland. So the beach always feels cooler than, say, if you go on the other side of the hills. Every moment of every day, winds are blowing across Earth. Some are mild, while others are quite strong. Yet all the winds form for the same reason: the sun heating Earth unevenly. If all points on Earth were at the same temperature, no winds would blow at all. Main idea and details. Describe some convection currents in nature. So, some convection currents in nature include sea breezes and land breezes, which are called local winds. Cool air always blows towards the warmer area. The warm air always rises, and the cool air always blows in to replace it. In the day, the cool air is blowing in towards the warm land. At night, the cool air is blowing out towards the warmer sea. Okay, another type of convection current in nature is the oceans. Warm ocean water at the equator flows north and flows south toward the poles, the cooler areas, just like the convection currents in the aquarium, creating huge loops of convection currents around the Earth. So it's happening both in the atmosphere and the oceans. All right, that was a short one today. Lots of reading, but not a lot to write down. So a lot of words to cover, some actually simple concepts, especially because we already know about convection currents from tectonic plates. Good job persevering with the growth mindset. Roar, Wildcats!